So in this video we're going to learn how to calculate equivalence and normality to units that are going to be new to us, but they'll be very similar to ones we've had in the past. Let's start off by talking about acids. Now that's the next chapter's topic, but let's get a little introduction here. An acid is an acid, at least according to one definition, because it ionizes in water to form hydrogen ions. There'll be other definitions as we'll see going forward, but for now, pretty good definition of an acid is something that forms hydrogen ions when you put it in water. So let's get a couple of other terms here. Monoprotic and polyprotic. Mono means one, and protic in this case refers to protons. You may remember that a hydrogen ion is a hydrogen atom that has lost its electron, and so therefore it's just a proton. So monoprotic means one hydrogen ion, and polyprotic, then it follows, would mean many hydrogen ions. Let's look at an example here. A monoprotic acid like hydrochloric acid will ionize in water and form a hydrogen ion, H+1, and the chloride ion. And then a polyprotic acid like, let's say, sulfuric acid in water will ionize to form two hydrogen ions and a sulfate ion. And so the difference between these two is simply that we get one hydrogen ion for every HCl with hydrochloric acid, and we get two hydrogen ions for every sulfuric acid with the sulfuric acid. So we get twice as many hydrogens. So if you will, sulfuric is twice as good at being an acid because it provides twice as much hydrogen. All right. So as I said, we're going to learn some new units here. The equivalent is defined as that amount of an acid that gives 1 mole of hydrogen ions. Okay? Equivalent is the amount that gives 1 mole of hydrogen ions. And so the equivalent mass is the amount of substance that will give 1 mole of hydrogen ions, specifically the mass of that substance. This is very similar to the mole and the molar mass definitions, except in this case we are just talking about the amount of hydrogen ions, and then the equivalent mass is the mass that gives you 1 mole of hydrogen ions. So those are just the definitions. We will do example problems on a separate video. So to calculate equivalent mass, we would just simply take the molar mass of the substance that we're talking about and divide it by the number of hydrogens. It's very simple. You can add up molar mass, then just look at how many hydrogens there are, divide by the number of hydrogens, and you have the equivalent mass. Now, how does it work for bases? It works exactly the same for bases. Bases use hydroxide, or bases have hydroxides instead of hydrogen ions. So if we go back here and look, then the equivalent of a base is the amount that gives 1 mole of hydroxides. The equivalent mass is the mass that gives 1 mole of hydroxides. The equivalent mass will be the molar mass divided by the number of hydroxides. So basically, works the same for bases as it does for hydrogens. Okay, now once we have equivalence, there's another unit we can do, and that's called normality. It's supposed to sound a lot like molarity because it's similar. Remember that molarity is a number of moles of solute per liter of solution. Normality is defined as a number of equivalents of solute per liter of solution. So the easiest way to figure normality is, if you know how to find molarity, then you just figure the molarity and multiply it by the number of hydrogens or hydroxides you see in the formula. It's that simple. Find the molarity, moles per liter, and then multiply it by the number of hydrogens or hydroxides. Now, why would we need this new unit? Well, it turns out that this unit helps a lot with stoichiometry problems. It makes them much easier if you have normality. Normality basically takes the mole ratio step out of the problem. So instead of having a 4-step problem, you have essentially a 2-step problem. You balance the equation, and then you know that one equivalent of an acid exactly neutralizes one equivalent of a base. Remember the neutralization reaction. The acid and the base produces water and a salt. And so if that's the case, we just set up this simple little equation that the normality of the acid times the volume of the acid has to equal the normality of the base times the volume of the base. So instead of doing a 4-step problem, get a written and balanced equation, do some calculations, or you take the givens and plug them into this equation. As long as we know 3 of them, we can find the 4th. All right, so that's the end of this video. There will be example problems on additional videos.